we will be studying the first chapter in physics, units and measurements. Physics is branch of science concerned with the nature. In physics, we study various laws of nature. It is called as quantitative science because we have to measure a number of physical quantities while performing various experiments. In our day-to-day life also, we need to measure a number of physical quantities, such as weights of fruits and vegetables, volume of liquids, length of cloth, body temperature, and so on. So let us understand what are these physical quantities. Quantities which can be measured are called as physical quantities. For example, time is equal to 30 seconds. So we have measured time as 30 seconds. So time is a physical quantity. Time is measured as 30 seconds. The number is called as magnitude. So magnitude is equal to 30 and unit is second. Another example of physical quantity is distance. Distance is equal to 3 meter. Over here, distance is measured. So distance is a physical quantity. Its magnitude is 3 and unit is meter. So time and distance are physical quantities. You can look around and check for some more physical quantities around you. The area of the room can be measured. The volume of the room can be measured. Hence, area and volume are physical quantities. The temperature of the room, the speed of the fan, the intensity of the light, all these quantities which can be measured can be called as physical quantities. We have seen that whenever physical quantities are measured, it is written as magnitude and unit. Magnitude is the number and unit is the standard of measurement. Let us understand what do we mean by unit. Unit is a standard measurement. When we say 1 meter, it remains the same all over the world. 1 meter for every person measuring will remain the same. So 1 meter is standard measurement. So meter will be called as a unit. 1 kilometer remains the same for everyone around the world. So it is a standard measurement. Hence, kilometer is a unit. Other example of unit is gram, kilogram, and so on. In school, we have studied various systems of unit. Let us recollect various systems of unit. CGS system. CGS system is centimeter gram second system. If we are making use of this system for measurement, the length of the object has to be measured in centimeter, the mass of the object has to be measured in grams, and the time has to be measured in seconds. Another system of unit is MKS. If we are making use of MKS system of unit, the length of the object has to be measured in meter, the mass of the object has to be measured in kilogram, and the time interval related to the object has to be measured in second. Other system of unit is FPS, foot pound second system. If we are making use of this system, the length of the object has to be measured in feet, the mass of the object has to be measured in pound, and time interval related to the object has to be measured in seconds. In earlier times, scientists of different countries were making use of these three different systems of units. In some countries, people were making use of MKS system. In other countries, they were making use of FPS system. Someone was making use of CGS system. So since different countries, people from different countries were making use of different systems, there was a need for one single system because different books, different articles were written in different systems of unit. So in 1971, the 14th International General Conference on Weights and Measurements recommended the use of International System of Unit. This international system of unit is called as SI. SI is System International. Since everyone had accepted SI system of unit, many of the countries started making use of SI all over the world. So it was now easier that everyone is making use of one homogeneous system of unit. Also, in the previous three systems of units in CGS, MKS and FPS, they have mentioned only 3 units each. But in SI system of unit, they have mentioned 7 units. So let us study SI system in detail. SI system consists of fundamental quantities and units, derived quantities and units, supplementary quantities and units. Let us see what are these fundamental quantities and units. The physical quantities which do not depend on any other physical quantities for their measurement are known as fundamental quantities according to SI. Let us see the examples. Length. While measuring length, we don't need to measure the mass of the object or time of the object or temperature of the object. So length will be termed as a fundamental quantity according to SI. So if we are measuring length, its SI unit is meter. If we are making use of SI system, length has to be measured in meter. If we are measuring mass, its SI unit is kilogram. Time is also a fundamental quantity and its SI unit is second. Electric current is a fundamental quantity and its SI unit is ampere. Temperature is a fundamental quantity and its SI unit is Kelvin. Amount of substance is a fundamental quantity, its SI unit is mole. And luminous intensity, meaning intensity of light, is also taken as fundamental quantity in SI and its SI unit is candela. So here you see there are 7 fundamental quantities and 7 fundamental units of those quantities. As in previous units or previous systems of units, they were just 3 units which we were talking about. But in SI, there are 7 fundamental units. Along with fundamental units, SI system also gave derived units. Let us understand what are these derived units or derived quantities. Quantities which depend on other quantities for their measurement are called as derived quantities. As the name suggests, quantities which are derived from other quantities will be called as derived quantities. Example, density, speed, momentum. Let us understand what are these derived quantities. The formula for density is mass upon volume. So density is derived from two other physical quantities, that is mass and volume. So density is a derived quantity. Unit of density is equal to unit of mass upon unit of volume, which is equal to kg per meter cube. Another example of derived quantity is speed. Its formula is distance upon time. So it is derived from two other quantities, that is distance and time. So speed will be termed as derived quantity. And let us find the unit for speed. Unit for speed is equal to unit of distance upon unit of time, which is equal to, what is unit of distance? Meter, and unit of time is second. So meter per second. One more example of derived quantity. Momentum. The formula for momentum is mass into velocity. So momentum is derived from two other quantities, that is mass and velocity. Hence, momentum is a derived quantity. Let us find unit for momentum. Unit for momentum will be equal to unit of mass into unit of velocity, which is equal to kg into, what is unit of velocity? Meter per second. When you multiply it, you write it as kg meter per second. So we have understood what are derived quantities. Derived quantities are the quantities which require other quantities for their measurement, or which are derived from the other quantities. So we have studied about fundamental quantities and derived quantities in SI system of units. So let us identify the following quantities as fundamental and derived quantities. First example is force. The formula for force is mass into acceleration. So force is derived out of two other quantities. So force will be termed as derived quantity. Temperature, you do not require anything else to measure temperature. So temperature will be termed as fundamental quantity. Electric current also comes under fundamental quantity. Velocity, the formula for velocity is displacement upon time. So it is derived out of two quantities, that is displacement and time. So velocity is a derived quantity. Acceleration, the formula for acceleration is velocity upon time. It is derived from two other quantities. Hence, it will be derived quantity. Time is fundamental quantity. Momentum, the formula for momentum is mass into velocity. So, it will be derived quantity. The formula for pressure is force upon area. So, pressure is a derived quantity. The formula for density is mass upon volume. Hence, it is also a derived quantity. Distance is fundamental quantity. Area is equal to length into breadth. So, we have derived area from length and breadth. So, it is derived quantity. Volume is also derived quantity. Speed is also derived quantity because the formula for speed is distance upon time. And energy is force into displacement. So energy is also derived from two other quantities, hence it will be called as a derived quantity. So in SI we have seen there were 7 fundamental quantities, those 7 quantities which were written in that table. Along with those 7 fundamental quantities, it has a number of derived quantities. All the quantities that can be derived out of fundamental quantities will be termed as derived quantities. In SI, along with fundamental and derived quantities, there are two other supplementary quantities and their units. Let us see which are those two supplementary units. First is plane angle, denoted by theta. It is the angle which is formed between two lines when we have a circle. It is in 2D, and those two radius of the circle forming an angle will be called as a plane angle. The formula for plane angle is the length of the arc. Over here, arc is CB, and the radius of the circle, that is AC. And the unit of plane angle is radian. So SI unit of plane angle is radian. Second supplementary quantity is solid angle. What do we mean by solid angle? Now, instead of considering a circle, think of a sphere in 3D, wherein a cone part of the sphere will form an angle at the tip over here. This angle which is formed at the tip of the cone will be called as solid angle. The formula for the solid angle is area of the portion of the surface of the sphere, that is the surface area, divided by the square of the radius of the sphere. Its unit is steradian. So there are two supplementary units. First is for the plane angle, the unit is radian, and for solid angle, the unit is steradian. So let us revise what is SI system of unit. SI system consists of 7 fundamental quantities and their units, many number of derived quantities and their units, and 2 supplementary quantities and their units. So today we have studied about different systems of units: CGS system, MKS system, FPS system, and we have studied SI system in detail.